The F-15EX Eagle takes flight, ready for combat.
Positive rate, gear up.
Roger, touchdown. The aircraft flew perfectly.
Welcome to where we build the F-15EX Eagle fighter jet.
Carbon fiber materials are stored frozen to preserve their properties.
Robotic systems place carbon fiber with micron-level precision.
Complex sections require skilled hand layup by expert technicians. Vacuum bagging prepares components for high-pressure autoclave curing. Components enter autoclaves for high-temperature pressure curing.
6-hour cure cycles transform materials into aerospace-grade structures.
Cured components emerge as solid aerospace-grade carbon fiber structures.
Temperatures are stable, clear to extract.
Ultrasonic scans verify perfect internal composite structure integrity.
50,000-ton presses forge titanium into structural bulkheads. Heat treatment optimizes titanium strength for extreme flight stresses. Titanium billets heat to 2,000 degrees for forging. 5-axis CNC machines prepare for precision titanium cutting.
Diamond tooling machines titanium to tolerances of thousandths of inches.
Coordinate measuring machines verify precision to millionths of inches. Anodizing provides corrosion protection for decades of service. Final inspection ensures every titanium component meets exacting standards. Precision jigs hold fuselage frames in perfect alignment.
Robotic systems drill thousands of precision fastener holes.
Hole diameter looks good on screen.
Borescope confirms surface integrity.
Every fastener is torqued precisely and individually verified. Aluminum skin panels are precision fitted to the frame. Thousands of rivets permanently join skin to structure.
Aerospace sealants ensure fuel containment and corrosion protection.
Miles of wiring harnesses connect all aircraft systems.
Reading 42B07.
Confirmed, 42B07.
Completed fuselage sections undergo rigorous quality inspection.
Massive wing spars form the structural backbone of wings.
Precision ribs establish the wing's exact aerodynamic shape. Complex leading-edge slats enhance low-speed handling performance. Hydraulic presses form wing skins into precise aerodynamic curves. Wing skins must align within thousandth for perfect aerodynamics.
Automated systems install thousands of flush rivets perfectly.
Sealed integral tanks hold thousands of pounds of fuel. Completed wings pass rigorous three-dimensional quality verification.
Titanium stabilizer spars withstand extreme aerodynamic forces.
I've adjusted the feed rate for the new tool.
The surface finish looks consistent now.
Precision mass balancing prevents dangerous high-speed flutter. Heated bonding creates incredibly strong, lightweight control surfaces. Electro-hydraulic actuators provide instant, precise control and surface movement.
Test stands verify actuators survive thousands of flight cycles.
Leading-edge flaps deploy for maximum maneuverability. Double-slotted flaps provide exceptional low-speed lift capability.
Integrated testing verifies all flight controls respond perfectly.
Rudder cycling, check. Ailerons synced.
Ultra-strong landing gear forgings withstand extreme impact forces.
Precision heat treatment creates optimal strength and toughness.
Machining achieves tolerances of 0.5 of an inch.
Shock struts absorb tremendous landing impact energy smoothly.
Carbon brakes handle extreme energy from high-speed stops.
High-pressure tires support extreme loads at high speeds. Main landing gear bolts handle aircraft's entire weight.
Landing gear testing verifies reliable retraction and extension.
Single crystal blades withstand temperatures exceeding 2,500 degrees.
The airfoil tolerance is exactly as specified, plus or minus 0.001.
Verified. The optical comparator shows a perfect match to the CAD model.
Plasma temp stable at 15,000 degrees Fahrenheit. Thickness is steady at 12 thousandths.
Adhesion confirmed. TBC application successful.
The fir tree slot tolerance is holding steady at plus or minus 0.2.
Disc balance is verified within limits.
Each turbine blade is precisely positioned and locked.
Check the clearance on stage 6.
It's within tolerance, measuring 0.42.
All right, let's proceed with the stator lock. Igniter test sequence initiated. Confirming nozzle pattern.
20 dual orifice nozzles verified. Stand by for the spark.
Test complete. Parameters are stable.
Alignment confirmed. Proceeding with the torque sequence.
Rotor turning smoothly, verification passed.
All right, sign off on the documentation. Thousands of cooling holes protect afterburner from extreme heat.
Pressure test is holding steady at 850 psi. No leaks detected.
Excellent. The radial pattern looks uniform across all 72 nozzles. The specifications require a precise V-gutter angle here.
Confirmed.
Spacing is within tolerance on the laser gauge now.
Initiating cycle test sequence now. Pedals moving smoothly through full range. Geometry holds. Looking good. Confirmed. Calibration successful on all 6 actuators. Concentricity is holding within tolerance. Confirmed. Ready for full cycle test.
Bring it down slowly. Watch the alignment.
Looks perfect. Let's get the bolts in. Torquing to specifications now. Synchronization within spec at 850 square inches.
Cycle complete. Test successful.
Serial number 12345 confirmed. Thrust rating is correct.
Excellent work, team. This engine is accepted for test cell operations.
Cockpit structure provides foundation for all pilot systems.
Sequencer indicates green on stage 3. Drogue chute connection secure.
Verified. The catapult torque is within limits. Ready for sign-off.
Okay, easy now. A little to the left.
Got it. Looks aligned on the rails.
Connectivity is nominal across all MFDs.
Verified. The interface is fully responsive.
Aileron input nominal. Rudder feedback within tolerance. All switches cycling correctly.
Alignment is complete. The pitch ladder and flight path are synchronized.
Verified. All parameters are within tolerance.
Initiating canopy close sequence. Watch the pressure.
Steady rise. System check screen.
Oxygen system, check.
Displays are fully synchronized, verifying flight data inputs.
HOTAS response is nominal. All systems operational.
AESAR radar arrays contain thousands of individual transmit-receive modules.
Confirm alignment sequence initiated.
Cooling lines engaging, pressure steady, data bus secure.
Foresight locked at 0.05. Green for installation complete.
Initialization sequence is complete. All parameters are reading nominal.
Confirmed. The ADCP is online.
Okay, the radar warning receiver cable is secure. Copy that.
Moving to the jamming pod alignment now. Initiating alignment procedure. Check GPS lock.
GPS is active. We are showing alignment in progress, under 10 meters accuracy.
Com check. Radio 1, how copy?
Loud and clear. Systems are fully integrated and operational.
We need to verify the routing for the primary data bus right here.
Verified. It matches the architecture diagram.
Continuity check on channel 3 is good.
Radar operational, nav systems aligned, looking good on the main bus.
EW suite is ready. All green from here.
Integration test complete, ready for flight ops.
Weapons pylons carry missiles and bombs on external hardpoints.
Baffle 7 is clear, send it down. Roger that.
Pressure stabilizing at 8 psi. Initiating stroke test sequence.
Clear?
Reading confirms 14-inch ejection stroke.
Excellent, within tolerance. Interface circuits are good. Run the lock-on sequence test now.
Copy that. Test successful.
Align the hydraulic drive now.
Roger that. Ammunition feed system is secured and ready.
Final check on the spent case routing. Looks good.
SMS initialization complete. All weapon stations active.
Confirmed. System check passes. Ready for flight control interface.
All circuits verified. Mechanical retention check complete.
Copy that. Loadout is confirmed successful.
Targeting operational. All stations ready. Sim sequence initiated.
Acknowledged. Commanding release.
Release successful. Check complete.
Forward fuselage sections prepare for critical mating operation.
We are good to proceed. Take it down slowly.
Copy that. Easing the load.
Alignment is green across the board.
Starboard side alignment confirmed. Mate plane is flush, all pins engaged on the checklist.
Roger that. Moving to fasteners.
Position 42, 125 foot-pounds.
Verified and documented.
Witness mark applied, moving to 43.
Electrical harness 47 mated and secured.
Hydraulics check complete. Pressure holding steady.
Fuel lines joined. Continuity confirmed.
Easy now. Bring her down another 2 inches.
We're clear on the starboard side, boss.
Angle holding steady at 45.
The actuator connection is secure. Test cycle complete. Rigging is nominal at 25 degrees.
Confirmed. Looks good.
All points verified. The airframe meets quality standards. We are clear for engine installation.
Redundant electrical systems ensure reliable power to all aircraft.
Okay, running the continuity test on channel 4 now.
Signal is solid. Looks good here. Fully shielded.
Copy that. Proceed to secure the clamps.
FADEC data lines are secure. Cross-check the T2 sensor input.
Signal integrity confirmed. All readings nominal.
Firing circuits online. Station 12 signal path is green.
Good. Log that as complete. Compile the station checks.
Already on the tablet. Team lead.
Make sure that anti-skid harness is routed clear.
Continuity check complete on the sequencing circuits.
Gear down and locked, confirmed.
Check the connection on the boost pump controls.
Wiring is secure. Refueling circuits are online.
Automation logic responding correctly.
Navigation lights steady burn. Check.
Affirmative. Activating anti-collision strobes now.
Strobes are firing. Test the landing lights.
Landing lights on.
Electrical systems integration test, phase 3.
Power distribution is normal.
All systems functional. We are green for ground runs.
Twin F-110 engines install into aft fuselage bays.
Pressure's holding steady at 3,000 psi.
Roger that. UV inspection complete, no leaks detected.
Copy. Logging the pass now.
Final sweep initiated. Ailerons, stabilators, and rudders.
Confirmed functional. We are green across the board.
We are seeing a successful navigation alignment. How's the EW suite looking on your end?
All parameters are nominal. Confirming the pass now.
The emissions are stable and well within the limits here.
Confirmed. Susceptibility requirements are met across all bands.
Verify transfer sequence initiated. Flow rates match the schematic. Pumps are operating correctly.
Simulating low fuel now. We have a confirmed warning indication.
Missile rails operational. Gun circuits functional.
Copy that. All stations report route ready. System.
Go.
Final ground check complete. Aircraft is cleared for engine runs.
Great work, everyone.
Engine 1 stabilized, moving to engine 2.
First engine start brings the F-15EX to life.
Throttles advancing, military power, steady. Engaging afterburner now. Stable ignition on both engines, green across the board. Anti-skid engaged, pressure holding steady at 2,500 psi.
Roger that. Temperature's nominal. Steering check next.
Brake application successful, good feel. How's the gear look from behind?
Gear looks good. Center line is solid.
Airspeed alive, 100 knots, 120 knots.
Abort, abort.
Maximum braking.
All right, focusing on the initial envelope expansion maneuvers. Chase is ready.
Weather is clear. Winds 270 at 10 knots. Visibility 10 miles.
Good to go on the profile.
Rotate. Positive rate. Gear up.
2001 is clean, looking good.
Roger, touchdown. The aircraft flew perfectly. All systems performed as designed.
Yeah. Congratulations, team. What a beautiful landing.
That's how the F-15EX Eagle II is built for air dominance.
After CMS 70.